Hello, my name is James Dibelka, and this is for ASU's FSE 100 course for Random Team 13 Deliverable 4. So the idea behind my device is that it will attach to the back of a speaker cabinet, and the servo motor will attach directly to the volume knob of that speaker cabinet. Then I have a potentiometer acting as a microphone in, which is not available in TinkerCAD, but this still allows me to work out the logic. And the photoresistor here will sense the light levels in the bar, which is the environment that this will be used in, and then there's 3 LEDs that will communicate information to the sound guy. I'll quickly scroll through my code. Okay, and I'll quickly go through this. This is just declaring a bunch of pins. This is 2 variables I'll declare later, another pin that I'm declaring, and this is the most important part of this section, where it will turn the servo to 90 degrees at initially, which it will be the middle of the range of the volume knob on the speaker. And then declaring what the servo is going to be called. And now this is a bunch of pin mode stuff. This is the servo attach line, and this is the serial line, the serial begin line. In the void loop, where the most of the logic happens, mic in represents an analog read of the potentiometer, and photo in is an analog read of the photoresistor. Then I write all 3 LEDs to low. I write the servo to the servo angle, and in this case it's 90 initially, 90 degrees, and then it will print the mic in values in the serial monitor. Then this if statement will determine if the light levels are above or below 400. This is arbitrary because I can't test this, but the idea is that if the light levels go below 400, then the bar is closed and the machine does not need to be on, so it does not go through this loop. But if it is above 400, then the lights are on in the bar, and then the machine will come back to life. Now, it is reading the mic in value, which is an analog read from the microphone, and that will it will parse it into one of these 3 tiers. Now, all of these numbers are arbitrary because I couldn't test them, but they're supposed to represent safe listening levels on this bottom tier. This middle tier is supposed to represent dangerous hearing levels over time, and this is supposed to represent dangerous hearing levels immediately. And so we will start the simulation. You can see that this initially turns to 90 degrees right in the middle, and the lights are off in the bar, and the potentiometer is reading 0 down here in the serial monitor. If I turn the lights on in the bar, then the green LED will come on because there is no sound coming out of the speakers. Now, this would obviously, with no sound, is a safe listening level, but if we go ahead and turn this up, now we are partying. If this gets too high, we'll say 650, then the yellow LED will kick on and we'll be in the second tier. And once this happens, it will slowly, at 1 degree a second, turn the volume knob down with the servo motor. And the slow fade over time is to ensure that there is no loss in quality of the music. But if we continue getting louder and it gets far too loud, then it will start moving at 5 degrees a second, completely disregarding any smoothness of transition in the music. And then over time, because it's a closed loop system, this will turn the volume down enough to get it back into this green zone, in which case we're back to safe listening again. The music will shut off for the night, and they'll clean up and turn off the lights at the bar. And once that does, all of the lights will automatically shut off, ready for opening the next day. Thank you for your time.